Welcome to the Deep Dive. This is where we plunge into complex topics and, well, try to resurface with the clearest, most important insights for you. Today, we're pulling back the curtain on some really unsung heroes of the internet. We're talking about the invisible managers of digital traffic API gateways. Specifically, we're going to dive into three big ones: Spring Cloud Gateway, NGINX, and Kong.
Right. And our mission today, it isn't just, listing features. We're really trying to extract the most important insights from our sources. Think of it as a shortcut for you to understand these crucial tools, their differences, and maybe most importantly, why they are so vital for modern software architecture. Especially when you're dealing with microservices, it's really about knowing the right tool for the right job.
Yeah, exactly. You can think of these tools as the ultimate traffic cops, maybe even the bouncers for the digital world. They stand right at the front door of your applications, basically deciding who gets in, where they should go, how much traffic can flow at once. They're the ones making these incredibly complex distributed software systems actually work together seamlessly. Without them, it could easily be chaos, like a digital free-for-all. So, okay, let's start maybe by quickly clarifying what an API gateway even is in this whole context. Imagine you've got dozens, maybe hundreds of tiny independent services, microservices, all working together to power just one application. An API gateway acts as that single front door, that entry point for all the requests coming from clients. Instead of clients needing to know app and call every single microservice directly, which would be a nightmare, they just talk to the gateway. And this centralizes really vital functions like security, rate limiting, monitoring. It takes that burden off the individual services.
Exactly. It's a critical abstraction layer. It simplifies life for both your developers and your users. And speaking of the specific tools that do this job, let's meet our contenders, maybe starting with Spring Cloud Gateway.
Okay, sounds good. So Spring Cloud Gateway, it's open source, it's Java-based. Crucially, it's built right on the Spring ecosystem. That means it's designed really from the ground up for cloud-native applications. And it integrates, well, pretty seamlessly with Spring Boot and the whole Spring Cloud suite.
Yeah, and what's really impactful there is that deep integration with Java. It gives you dynamic routing so it can adjust where requests go on the fly. It has robust filtering capabilities, and it incorporates crucial resilience patterns right out of the box. We're talking about things like circuit breaking. That's the thing that prevents a failing service from dragging down your whole system by, temporarily cutting off traffic to it. And rate limiting, which controls how many requests someone can make, preventing abuse or overload. Its configuration is heavily Java-based typically, and it integrates super tightly with other Spring tools like Eureka for service discovery. So your gateway automatically knows where all your services are, even when they move around.
Okay, so if your team is really, steeped in that Java world, the Spring ecosystem,
Yeah.
and maybe you prefer defining your application's behavior through code rather than separate config files, then Spring Cloud Gateway often sounds like the perfect fit. It really seems to shine for those Java-centric microservices where programmatic control is, well, king. All right, next up, we have a real veteran in the field, NGINX. This one's also open source, high-performance web server, reverse proxy. It first came out way back in 2004. It's famous for its lightweight, event-driven architecture, which basically means it handles tons of concurrent connections really efficiently. It processes requests asynchronously, instead of dedicating a whole thread to each one.
Absolutely. NGINX truly excels in raw performance, its key features, serving static content incredibly fast, powerful load balancing, caching data that gets accessed a lot, and SSL/TLS termination. That last one, SSL/TLS termination, it means the gateway handles all the encryption and decryption work for secure traffic. That offloads a significant computational burden from your backend services, and its configuration is declarative. You basically tell it what you want the system to do, usually through pretty easy-to-read config files, rather than writing code for how to do it. This makes it incredibly versatile. It can handle a huge range of tasks, not just being an API gateway.
So if your application needs to handle just massive amounts of traffic, really low latency, across pretty much any environment, NGINX sounds like a rock-solid workhorse. It seems like the performance gold standard, especially when pure speed at that network layer is your biggest concern. Okay, then there's Kong. Kong is another open source API gateway, a bit younger. This one came out in 2015. But here's the interesting twist.
Yeah.
It's actually built on top of NGINX.
Yeah.
So it takes NGINX's already impressive performance and then extends its capabilities, specifically focusing on API management.
Yeah, what's really clever about Kong is exactly that. It leverages NGINX's speed underneath, but adds this comprehensive plugin-based layer for API management right on top. Its key features really revolve around this plugin-based architecture. That means you can add serious functionality, things like authentication, more advanced rate limiting, logging, monitoring, just by enabling and configuring these plugins. You don't have to write custom code in every single one of your back-end services to handle these things. It really shifts the way you think about API security and traffic shaping. It moves from bespoke code scattered everywhere to a highly configurable, almost low-code interface right at the gateway. Plus, it integrates really well with cloud-native tools like Kubernetes.
Okay, so if you're working with architectures that are really heavy on APIs, microservices talking to each other constantly, and you need serious extensibility, maybe a rich ecosystem of pre-built functions, and that centralized API management, Kong often becomes the preferred choice. It's about standardizing things and maybe speeding up how you roll out features across your whole API landscape. Okay, so we've met the players, we've seen their basic strengths. Let's maybe unpack this a bit more. Why do teams actually choose these specific tools? What makes them so indispensable in, a real-world project? What's the philosophy behind each one?
Well, starting with Spring Cloud Gateway again, its why is really deeply rooted in that seamless Java ecosystem integration. It's designed to work like hand in glove with Spring Boot, with Eureka for service discovery, all the other Spring Cloud components. This lets Java developers leverage the tools and patterns they already know really well. It reduces context switching, usually leads to faster development, fewer integration headaches. Your gateway logic can essentially live right alongside your application code.
Right, and that ties directly into its programmatic configuration, doesn't it? You
Sure.
define routes and filters directly in Java code, or maybe YAML, which gives developers this incredibly fine-grained, code-based control over how requests get handled. It sounds perfect for teams who just prefer managing that logic directly within their familiar development environment.
Exactly. And this also circles back to those resilience features we touched on. The built-in support for circuit breakers, usually via Resilience 4J in the Spring world, plus retries and timeouts. They aren't just features added on, they're like a core safety net. They're designed to automatically enhance the reliability of your microservices, preventing some small hiccup in one service from cascading into a major outage across the whole system. It's also inherently cloud native. It supports dynamic service discovery, dynamic configuration management, which you really need in today's, dynamic cloud environments.
Okay, moving on to NGINX. Its why often seems to boil down to just pure raw performance and versatility.
Absolutely. NGINX's event-driven architecture makes it incredibly efficient. We talked about that. It can handle thousands, potentially tens of thousands of concurrent connections using minimal resources. That's ideal for those really high-traffic situations where every microsecond counts. It's often the choice when raw speed and efficiency right at the edge, right where traffic first hits, is the absolute top priority. It acts like this minimalist but very powerful shield.
And it's incredibly versatile too, right? It functions as a web server, a reverse proxy, a load balancer, and an API gateway. That adaptability means it can fit into a huge range of use cases, sometimes doing multiple jobs at once. It really is kind of the Swiss Army knife of web servers, handling many roles with very little overhead.
And connecting that to the bigger picture, NGINX provides those critical security features we mentioned. Rate limiting, IP restrictions, SSLTLS termination. These are just fundamental for securing any application right at the perimeter. Plus, its scalability is, immense. You can scale it horizontally across multiple servers or containers quite easily, supporting growing workloads without really breaking a sweat. It makes it a highly reliable traffic cop even when things get really busy.
Okay, now for Kong. The why for Kong really seems to center on that robust API management piece.
That's right. Kong is all about centralizing API routing, authentication, monitoring. It dramatically simplifies how clients interact with all your potentially numerous backend services. It's about making API management less chaotic, more structured. It allows organizations to kind of treat their APIs as first-class products, providing this strong governance layer that's also easily extendable.
And its extensibility through that plugin ecosystem that sounds like a massive selling point. Instead of teams writing custom security logic or logging or data transformation code into every single microservice,
Yeah, which gets messy fast.
right, you offload those common concerns to these configurable plugins right at the gateway. It's like creating a reusable toolkit for all your API needs, which promotes standardization and probably speeds up development cycles quite a bit.
Definitely. And because Kong is built on NGINX, it inherits that high performance capability. So you get low latency handling for your APIs, which is crucial. Furthermore, its cloud native integration is really strong. It works seamlessly with modern tools like Kubernetes, Docker, fitting right into contemporary primary DevOps workflows. This makes it a really key component for managing traffic in modern containerized deployments. So, okay, now let's maybe talk about the pivotal roles these tools play, specifically within microservices architectures. These architectures, just by their nature, rely on lots of independent services talking to each other through APIs. That means you absolutely need robust gateways to manage all that traffic, handle security, ensure resilience. They really are the orchestrators of all that communication.
Okay, so looking at Spring Cloud Gateway in action in a microservices setup, its dynamic routing seems key. It routes requests based on flexible rules predicates. They call them like URL paths or request headers, all managed with that Java-based configuration we talked about. And it integrates tightly with service discovery tools like Eureka. So it's like having a smart traffic cop that can adjust routes instantly, making sure requests always find the right healthy service instance, even as your services scale up or down dynamically.
And its role in resilience is absolutely critical there. It implements those circuit breakers, retries, timeouts we keep mentioning. It actively prevents those cascading failures, which can be a complete nightmare in a distributed system if you don't manage them properly. It's that essential safety net, protecting your whole system from an issue in just one small part.
And on the security side, it supports filters for authentication, right? Like using OAuth or JWT tokens. So the gateway can handle that initial user verification step. It can also do things like request validation, adding another layer of protection right at the entry point.
Yeah, and what really stands out, I think, for Spring Cloud Gateway in this context is how much it boosts developer productivity, specifically for Java teams. Java developers really benefit from using those familiar Spring tools. It significantly cuts down the learning curve. Integrating the gateway feels like just another part of their normal Spring application development.
Okay, switching gears to NGINX. Its critical role often starts with it acting as both an API gateway and a load balancer, doesn't it? It's routing API requests, but it's also distributing that traffic across multiple instances of your microservices. That's absolutely essential for high availability and performance. It's your frontline defense and your traffic distributor, making sure requests get to healthy services efficiently.
Exactly. And its traffic management capabilities are actually quite sophisticated. It supports routing based on URL paths, request headers, even weighted routing for very flexible traffic control. This allows for advanced deployment strategies like A/B testing or canary releases, where you might send, say, 5% of your users to a new version of a service before you roll it out completely. And as we noted, it provides those strong security features. Rate limiting, IP whitelisting, SSL/TLS termination, all crucial for securing your microservices right at the edge. It acts like a pretty formidable digital bodyguard.
Now here's where it gets really interesting for modern infrastructure.
Yeah.
It's Kubernetes integration. NGINX is very commonly used as an ingress controller. What does that actually mean?
Right, so an ingress controller is basically the primary way you manage external HTTP and HTTPS traffic that's trying to get into your containerized services running inside a Kubernetes cluster. NGINX, in this role, acts as that crucial bridge between users outside the cluster and all your internal containerized applications. It's fundamental for exposing services in K8s.
Got it. Okay, finally, Kong's specialization. It really seems to shine as that centralized API gateway, simplifying API management by routing requests, enforcing policies consistently, maybe even transforming data as it passes through.
Precisely. It ensures consistent application of rules, security rules, traffic rules across all your different APIs, which is hard to do otherwise.
And that plugin ecosystem, again, sounds like a game changer for microservices, extending functionality with plugins for authentication, logging, rate limiting. It offloads all that complexity from your individual microservices.
Yeah, it stops developers from having to reinvent the wheel for common cross-cutting concerns in every single service. It's like having, as you said, a universal remote for all those API-related tasks. What's also really key here is its focus on observability. Kong provides built-in metrics and logs. These are just indispensable for monitoring how your APIs are performing and for quickly debugging any issues that pop up. It's like having eyes and ears on every single digital interaction happening at your gateway. And like the others, it also integrates seamlessly with service discovery tools, whether that's Console or Kubernetes itself, for dynamic routing to healthy service instances, ensuring reliability.
Okay, so to kind of wrap up this whole section, in microservices, these tools, Spring Cloud, Gateway, NGINX, Kong, they simplify communication between services, they enhance scalability, and they ensure security. They are absolutely foundational. They serve as these intelligent traffic controllers that make sure the entire complex system operates smoothly and reliably.
Yeah, and I think what really stands out here is that the choice among them, it ultimately depends on a few key things. Your existing ecosystem compatibility, are you primarily a Java shop, or do you need something more language neutral? Your specific performance needs, do you need absolute maximum throughput, or is comprehensive management more critical? And the level of customization and API management features your architecture demands. Each one is brilliant, but often for a slightly different primary purpose or context.
And there you have it, a deep dive into the, well, pretty powerful world of API gateways. We've seen the distinct strengths. Spring Cloud Gateway really excelling in those Java-centric environments,
Yeah.
focusing on resilience, programmatic control. NGINX, the versatile powerhouse, your go-to for raw, high-performance, general-purpose traffic management. And then Kong, which builds on NGINX, specializing in that comprehensive, extensible API management, making it a true command center for your digital services.
We've definitely seen how these tools are just fundamental for building robust, scalable, and secure microservices architectures today. They truly are the unsung heroes of modern software, silently making sure these complex systems work seamlessly for us every single day.
And perhaps that leaves you, our listener, with a final thought to mull over. How might understanding these traffic controllers for digital services, these tools that manage flow and communication, offer insights into managing other complex, interconnected systems, maybe in your own life or work? Systems where clear communication and efficient routing are also absolutely key to success. Something to think about.